Hello, and welcome to the Sparq Podcast. I'm Bren Piper, and myself, along with Calvin Rubens, hope to each week bring you a new podcast which will present to you everything new and innovative that is happening at Queen's University right now. This is our very first episode, and on the episode we have 4 of the 5 members of the Borehole Analytics company. BHA is a part of the Queen's Student Innovation Institute, which is a summer program run by the Queen's Innovation Connector. You can find links for both of these groups and for the BHA itself at the bottom of the video in the description. Just before we get into the actual episode though, I just want to let you know that this being our first episode and everything, there are a bit of sound quality issues at times, simply because we haven't fully accustomed to the setup yet. However, as the episodes move forward, I promise you this shall be improved upon. Alright, enough of all of this. Here's the first episode with BHA. So this is our inaugural Sparq Podcast. We're here. I am Bren Piper.
I'm Calvin Rubens.
Calvin Rubens beside me, and we have the Borehole Analytics team from QSII. So if you guys want to go around, introduce yourselves by name, tell us who you are.
Okay, I'm Brett Kolinkowski. I just graduated my engineering at Queen's, and yeah.
I'm Addy, just finished my 3rd year in economics and mathematics.
I'm Sean. Just like Brett, I just finished my 4th year at Queen's and have now graduated.
And my name's Oliver, and I'm going into my final year at Queensinnovation.
Excellent. So basically what we're going to do here, I already mentioned it to you guys quickly, but for everyone listening to this, we're just going to talk about what's going on with you guys in QSI right now in your Borehole Analytics company. So if you guys want to maybe just start off and describe what you're doing exactly, tell us about it. Whoever wants to go first, I'm not sure who wants to talk most about that. Sean?
Yeah, okay, so I'll kind of give you guys the story, if you will. So Brett, over here to my right, came up with the thesis. So his thesis was looking directly at boreholes. And, as a mining engineer, you'd think I would know something about boreholes. I didn't really know anything. All I really knew is you put explosives in them, and they're a great way to generate ore and generate money. But aside from that, I never knew you did inspections, but one of the requirements for us during our 4th year thesis was to sit in on our peers' 4th year thesis. And I'm on the last day of the thesis presentation, and Brett comes in and he does his thesis on kind of turning the entire borehole analytics, borehole camera and data acquisition industry on its head. Because typically, as I learned in this thesis, the camera companies right now use analog transmission and analog cameras, CCTV cameras, which are old school cameras. This is technology that's 15, 20 years old, old cable box technology for these cameras. And he said, well, why don't we bring the 21st century to the whole thing, turn the entire industry on its head? And I'll never forget sitting in there at the end of his thesis, and there he is with his tablet streaming video directly to his tablet, and I'm sitting there in the back, and I go, well, this is the future. And so that's when I thought to myself, maybe we can take this prototype to the product stage. And through QIC, they kind of gave us some money, $2,500, but most importantly, they gave us access to human capital. And we were able to assemble a really good team with Oliver, Addy, Austin, who unfortunately can't be here today, and obviously Brett. So we could try and take his prototype and his concept and bring it to the actual product stage.
Cool. For the layperson, what exactly is the purpose of a borehole and stuff like that in terms of mining?
Okay, so a borehole is you bore down and you can either get a rock core typically, and then you can tell the rock core what is in the rock core, but most importantly for us is being able to go down and see characteristics of the borehole, like joints within the borehole and water penetration, stuff like that. So we want to put a camera in there. Well, that's already being done. We want to put a camera in there and do better.
All right, cool.
Cool. So you'd mentioned that you want to bring the 21st century to these boreholes. So aside from just the camera, are you focusing on any other useful features of your technology that's going to be in these boreholes?
Yeah, definitely. We kind of looked at it as being more of a platform. And that's kind of the word. Peter Gallant, somebody here at Queen's, who's kind of acted a little bit of a mentor for us, coined that term for us, and it's kind of stuck. Yeah, definitely. The way that we do it gives us the opportunity to bring as as many different types of sensors as we want to complement the video feed, because at the end of the day, the mining industry is starting. They always lag under other industries to try and get into an era of big data, and that's what we're about. Is instead of having to have multiple pieces of equipment, laying them on the table and go, well, we're going to need this one, and have to spend the money for all of those. You go, well, we just need one, and that's BHA's unit. And so we're not talking about just doing a video feed. What we're talking about is giving you a platform through which to add a whole pile of different sensors, be that temperature sensors, pH sensors, dip and dip direction sensors, and all that is, for somebody who doesn't know rock mechanics, is just what's its 3D orientation in space. And from a geotechnical standpoint, when you're dropping your camera down to see where joints and fractures are, that's huge. Because if you're dropping a typical camera down and it's spinning, well, how do you know what's up, down, sideways, north, or west? You really don't. You throw a dart on the board and hope. But with ours, it'll go, okay, well, you're dipping at, say, 70 degrees at a dip direction of 281 degrees, and you go, okay, so here's the joint. I can map exactly where that is, bring it up into your software analysis, your post-processing, if you will. So yeah, that's the biggest thing, is we bring a platform to the industry.
Cool. This all sounds very interesting. I really like hearing about this stuff. Obviously you can't go too much into what's inside of your thing too much, just with knowledge, but if there is any side of the design process that you went through that you can mention, is there anything really that you can say that goes more specific?
So just sort of, general specifications of it.
Yeah.
We're designing for a 2.5-inch external diameter tube. It's going to be about 6 inches to a foot long, which is a bit smaller than the average unit. And then we're going to sort of be using, we'll have like a lens on the front with a camera, and then that will have a light ring of LEDs that will light up the whole, and then we'll have sensors sort of incorporated into the walls and of the device, which will be able to measure, like Sean said, temperature, pressure, pH, and sort of other things that we add on as we go.
Cool. And then will it have a separate screen system, or how are you planning on doing the actual viewing of the video?
Right now, the way we set it up is there's no need for additional screens. As long as you have your phone or your tablet or your computer, you don't need to buy additional gear with the camera, which a lot of these companies are doing right now. So we're going to get away from that, cut down the cost, and make sure that everyone, I want a bigger screen, good for you. Just get a bigger screen, go on our stream, and you can just look at it right on the spot.
Yeah, and
that's something that's really separating us from other competitors at this point.
Yeah, exactly. Just to continue, to hammer that point home, is for every single one of our competitors, you are required to use their tiny 7-inch little screen to view at maximum of 480p feed.
Oh wow! Yeah, so that's not the greatest of.
Well, it was great back in 1998.
Yeah, but in 2014.
Yeah. So you're looking at kind of getting away from proprietary hardware then, and letting consumers choose their own things, kind of bringing in not exactly a DIY aspect to it, but more choice.
Yeah, giving you flexibility. Personally, it's one of these things. It's funny, the little things you learn when you're talking to potential customers, but one of them was talking about how the sun's a huge issue. You have your screen and it's fixed on the unit, and the sun's beating directly over your head. Well, if anybody knew, you're trying to use your cell phone during bright sunlight, it's just ridiculous. You crank up the brightness and you still can't see anything, right? But with ours, you go, well, there's a tree right over there, so you just walk over with the tree, and you can conduct the whole thing just on your tablet or your laptop, right, wirelessly. It's not new technology, but it's brand new to this industry, and that's kind of our goal. So
I'm really interested in terms of what kind of electronic challenges are you guys facing right now, and are you handling these appropriately? Like, are you looking at doing a lot of wireless transmission, or like having a base station at all? What depths are you looking at using this equipment at?
Yeah, I can take that one. Sort of with anything, if you have data transmission or data and power transmission over a long distance, you start running into issues sort of with losses. So, you have to push harder on one end to get that transmission through. So, we have sort of experienced some issues with that, but right now we can do 100 meters no problem, and we're looking at expanding that quite significantly in the future. And And so yeah, it's just sort of basic electronics to make sure obviously have use as little power as possible down the hole, and then transmit as compressed video back, so we can sort of save as much bandwidth as possible.
Cool. So what are all of your positions kind of within your group?
Yeah, I can start. So my background is in mechanical engineering, so that's sort of what I'm taking the lead on right now, and that's designing the housing, designing the internal layout of all the components, and building connectors to sort of fit everything together.
I guess, so my educational background is mining engineering, and my outside of engineering educational background is business. I guess through this I've been taking kind of the project management and networking role, handling a lot of the business side stuff and trying to establish contacts within the mining industry so we can have streamlined deployment.
Cool.
Right, so my background's in economics and mathematics, but unfortunately that's not something I've been working on so far. And so far the past month I've been doing software side, so I've been working on the coding and all this transmission stuff between a couple of computers, network streams, and all that sort of stuff.
Okay, then I was in mining engineering. I originally came up with the idea, and that's kind of where I'm trying to stay, is just I keep coming up with ideas, and I'm having a piece of everybody's work, and I'm trying to pull it together and make sure it's all going to work together. So.
Cool. Excellent. And then, so this is a part of QSII. Can you guys give a bit of a description of QSII and exactly what that is? Because you guys would obviously know what that is for people that don't necessarily know what QSI is.
Yeah, okay, I can do that. So QSII is kind of part of the broader Queensinnovation connector. And really what it aims to do is, in a nutshell, put 30 or more of us into a box, give us a little shake, give us a little bit of money, and give us a little bit of direction and see where we end up. So what they've done for us is they gave us 2 weeks of kind of an opportunity to get to know each other, an opportunity to listen to a number of highly qualified guest speakers on a variety of topics, be it from IP, intellectual property, to accounting, to sales. And then at the end, go, all right, you guys have had an opportunity to meet everybody, split off into teams, form your teams, and then at the end of the day, we're going to give you guys, for each of your teams, $2,500 of no strings attached capital to try and get your business off the ground. In addition to that, we also get funding, and so we're the first to say that QIC, without QIC, this probably almost guarantee we would not be here today. So we owe a lot to QIC, and obviously, as I said earlier, QSII is just a sub branch of QIC. Basically, is the Queen Summer Innovation Initiative, and that's what we're part of.
All right, cool. And you're obviously enjoying the experience so far.
Well, it's got its ups and downs, right? Like, it's excellent. Our team dynamics are great. We got a great team, but it's a lot of work.
Yeah.
And startups, it's not an easy road. It's probably the toughest road. But it's QIC really helps foster us and try and get our business off the ground.
Yeah, I suppose when you have when some of your team and stuff has school coming up, that kind of, and you only have 4 months really to get a whole business off the ground, right from design on up, and even just forming your team, that would put a lot of pressure on it to work fast and hard and diligently, I suppose, right?
It does, yeah. It's a pressure cooker.
So you guys are about halfway through at this point, then, a little over halfway.
Yeah, that's interesting. We are technically halfway through the program, but really we're only a month in with our actual teams.
Mm-hmm.
Be that as in May. So yeah, we're halfway through the program, but we've only had a month to get to know each other and get our product off the ground, right?
Yeah,
of course. How far have you guys progressed in the prototyping department? Have you gotten any functioning prototypes of your work?
Yeah, we're actually on to finished prototype number 3, and we sort of went from initially using PVC tube. We then moved to cardboard. So there's a bit of a loss, we kind of lost waterproofing on that one, and then we moved up to using rapid prototyping with we have a facility called Sparq Labs, which this podcast is about, and we were able to use their 3D printer to create custom tubing, and sort of custom plates to mount all of our circuits and cameras and electronics. And so that was prototype number 3, and now we're moving on to prototype number 4, which will be made in the machine shop on campus, part of the mechanical engineering department.
Very cool.
Of course.
So you mentioned, one of the things you mentioned was obviously the waterproofing. What kind of other environmental kind of conditions does it have to be able to withstand and handle? Because you're obviously trying to go fairly far down into the ground, and in stone you're going to have different things that it has to handle. So what kind of things is that?
Well, you're going to have issues with abrasion on the sides of the wall. You want it to be rust proof, which is why we're going with stainless steel. And yeah, it's got to resist heat to an extent and shock. I mean, these are going to be old guys, old rough and tough miners using this thing, and they're going to drop it. So it's got to be tough.
Yeah.
Yeah, of course.
Cool.
Are there any existing industries that you've been drawing a lot of inspiration from? Because you said, I mean, this technology in terms of going down with a CCTV camera it's been around for a while, but you guys are revamping it. Is there any other industry that's really closely tied in with what you're working towards?
Medicine,
really? Oh, yes, because of like microcapsules and sending in tubes with cameras on the end for operations.
Yeah, and for colonoscopies and all that type of stuff, right?
Mm-hmm. Okay.
Doing a scope, a lot of these are similar technical background. Even GoPro, which you guys are using today.
Yeah.
This is kind of a similar ball game. When I have to describe this to some guys, say even my housemates, they'll go, oh yeah, so it's just like dropping a GoPro down the hole, and we're doing a lot more than that, but in just the optical sense, kind of, yeah, that's kind of what we're doing. You're trying to drop a robust camera down a hole that'll give you a extremely high quality digital feed that you can do whatever you want with.
Mm-hmm.
That's very cool.
But as you'd mentioned, it includes so much more than just that. I mean, there's a wealth of information that it's probably even just as valuable without the camera from all the sensor data that you're going to be getting.
Yeah, it is, and you know what, like side by side you have to do separate tests for each one, but together it's really streamlines the entire process.
Yeah, of course.
Cool. Running out of things to say. I'm not sure if there's anything. I'm trying to think of questions right now. Is there anything else that you guys wanted to say that you have in your head right now about BHA and different things like that that you want to get across that we maybe haven't touched on just yet? Is there anything you guys want to say?
Yeah, just a big thank you obviously so far to Sparq Labs. Without you guys we really wouldn't have been able to take our prototyping to the next level. It's certainly been a huge help for us personally.
Glad we can be of help.
I'm glad to see it's getting used a lot. Last summer, a lot of QSII didn't really know about it, so it's nice to see it getting some use and having the equipment
improve the service.
Exactly.
Goes hand in hand.
Yeah,
more accessible.
We've moved up from just being in group rooms like this to being in an actual design bay now in the ILC. So
with real tools.
With real tools and real equipment, and we got some impressive stuff down there now. So it's glad to know that it's being used to its full extent, and you guys are in there all the time. So it's nice seeing that.
Yeah. I mean, just other final things ending up. I mean, thanks a lot, Bren and Calvin, for inviting us out. I mean, it's sort of the pilot. So
it's our pilot.
Hopefully it makes it live. But if you want to sort of follow us, you can follow us at boreholeanalytics.com.
Perfect.
All right.
Excellent. Yeah. I think we can wrap it up there. Yeah, we'll see. Well, hopefully this will get uploaded online soon.
I'm glad that we did this, because going in I had absolutely no idea other than what your company name was. And I think the last time I had talked to you, Oliver, I saw your prototype with the shopping bag going up the railing. So I wasn't entirely sure on the details, but it was very informative. So thanks. You did a great job explaining your goals and your progress and what you're looking to get out of this. So it's a really interesting initiative you've got going.
Yeah. Hopefully if we keep this podcast going and stuff and people find it interesting, we can catch up with you guys in a couple months towards the end of the summer. See where it's at, how you've changed from now to then, and maybe we can get a prototype for people watching it on the video and have the prototype here and actually show it off a bit more so people can
see what's going on. If they're watching it, if they're listening, they might have a bit of a problem. But
And so, I mean, you're just one group of QSII students. How many groups are there in total?
There's 8 groups right now.
Okay, so
And one of them is working on corporate innovation.
okay,
So they're not going to be designing a product. They're designing more of a platform-based service.
all
Okay.
right. Wow.
That
So
could be interesting.
yeah,
Yeah, hopefully we'll get all the different QSI groups, including the corporate innovation, because that's interesting things still, and so we really want to get that. So, anyways,
yeah,
I
we got
guess
some follow-ups to do in the near future as well. So
yeah, for sure.
checking in.
Coming to a borehole near you.
Exactly. All right, perfect.